Hello grade 8 students. Here is summary 11 for week 11 and the topic is characteristics of specific immune response. Document 2. B lymphocyte produces 3000 antibodies per second. Wow, thank God, no bacteria can survive this. In all cases, antibodies bind and neutralize the non-self antigens. However, how many types of antibodies can each B lymphocyte produce? Moreover, some scientists propose that one type of antibodies could bind to many specific antigens. Others suggested that every antibody can bind to one specific antigen, but we still do not know the correct idea. Pick out the posed problem. From the text, the posed problem is how many types of antibodies can each B lymphocyte produce? Don't forget the question mark. Is the problem solved? Justify using figure 1. Okay, look at figure 1. If you see each type of B lymphocyte, each B1, B2, B3, each one of them is secreting only one type of antibodies. So we say yes, since each B lymphocyte produces one type of antibodies, as you see here. Pick out the two studied hypotheses from the text. Hypothesis 1, one type of antibodies could bind to many different antigens. Hypothesis 2, every antibody can bind to one specific antigen. Match each antigen to its possible antibody. Look at antibody A. What is the antigen here? Here it is J, if you see. J can bind to antibody A. Look at antibody B. It can bind to F. C can bind to H. G can bind to E. And I can bind to D. Derive a suitable conclusion. We conclude that each antibody binds to one specific antigen. Document 3, amplification process. Waking up feeling flu on an early morning doesn't mean you got the infection during sleeping, but it probably infected you before 24 hours. But why? Why was our immune system late to respond? To determine the reason behind this delay, we recorded the following events. Pick out the posed problem from the text. Why was our immune system late to respond? Do all types of B cells attack this virus? Justify. Look at the figure here. This figure is known as shows the amplification process that happens in our bodies upon infection. Look at the shape of the non-self antigen that is recognized only by B4, by the antibodies secreted by B4. So only B4 can recognize it and can attack this virus, not all B lymphocytes. So they are asking if all B lymphocytes can attack this virus. No, only the B lymphocyte B4 here that can recognize the virus will attack it. Can this lonely activated B cell eliminate the million invader viruses? What should happen? No, it cannot. It should multiply and increase in number. Then the produced cells undergo maturation. Pick out the names of the final obtained cells and indicate the function of each one from the figure. They are two types, plasma and memory. The plasma cells secrete antibodies into the blood. The memory cells memorize the antigen in case of future infection. Using all of the above, explain the delay of our immune systems to start defending us. The immune system delay is due to the amplification process where the immune cell must recognize, multiply, then differentiate or mature in order to defend the body. Therefore, it takes a lot of time. Document 4, primary and secondary immune responses. If you see, this figure is showing us the difference between primary and secondary response in their delay, in their duration, and in their amplitude. Okay, so part 1, construct a table that shows the delay, duration, and the amount of antibodies of the primary and the secondary response. The delay in days in the primary response, if you see the first infection by the virus is at day 0 and the delay is 3 days. So 3 days in the primary response. In the secondary, you can see at the second infection at day 120, and the secondary response started at 121, date 121. So the delay is only 1 day in the secondary. The amplitude is the highest amount of antibodies. In primary, it's 250 AU. In secondary, it's 500. Duration of the primary is 2 days, from 3 to 5, whereas the secondary is long-lasting. The title is a table comparing the primary and the secondary immune responses. Precise, the faster response. Precise, so we have to answer, then justify. They are asking us about the faster response. Faster, so we have to look at the delay time, okay? The secondary immune response is faster than the primary immune response since it starts after 1 day of the infection, less than the time needed for the primary response to start, which is 3 days. Identify the amplified response. Identify, justify, then answer. Amplified means the one that has a greater amplitude. We say since 500 AU of antibodies are produced during the secondary immune response, greater than the amount produced during the primary immune response, which is 250, then the secondary immune response is more amplified than the primary one. Determine the longer protection response. Okay, so determine, also here we have to justify the answer. Longer protection, we should look at the duration. Since the primary immune response lasts for 2 days, less than the secondary response that lasts for many days, then the secondary immune response is the longer protection response. The secondary response is more efficient than the primary one. Explain the reason behind this. Okay. The secondary immune response is faster, is more amplified, and it offers a longer protection than the primary immune response. Thus, the secondary immune response is more efficient than the primary one. Pick out the steps of amplification. First, we have recognition, then selection, then multiplication, then maturation according to the figure. Application 1. Immune system defends the animal bodies against any non-self antigen, and it works in a high professional way. In our search for some properties of this system, the following 3 graft experiments were done. Identify the type of the graft. Look, identify, so we have to start with the since the graft is done between 2 different mice, because from mouse of strain X to mouse of strain Y, they are different, then this is an allograft. Compare experiments 1 and 2. If you see in experiment 1, it was rejected after 12 days. In experiment 2, they repeated the same experiment after 40 days, and it was rejected after 3 days. In comparison, we have to start from similarities, then we move on to the differences. Here we don't have number to use, less than or greater than, right? So we say, both experiments 1 and 2 are done from a mouse of strain X to a mouse of strain Y. Both experiments got rejected. These are the similarities. But experiment 2 is the same as experiment 1, but repeated after 40 days. And the graft in experiment 2 got rejected in 3 days, less time than the time needed to reject the graft in experiment 1, which is 12 days. Conclude concerning an important idea of the immune system. We conclude that the immune system has an immune memory. Analyze experiment 3. In experiment 3, a skin graft is done from a mouse of strain Z to a mouse of strain Y. This graft got rejected in 12 days. Simply, we started from the variable, then the result. You can change it if you want from the result and the variable. Referring to experiments 1 and 3, derive a conclusion concerning an important property of immune system. We conclude that the immune system is specific.